Hi, myself and Arun Kumar from Astos College of Technology in the Department of EC. In this video, I am going to share about a network layer in the Internet Protocol version 4 and Internet Protocol version 6. Internet Protocol version 4, the network layer protocol in this TCP/IP protocol is suitable for IP version 4. Although the IP version 4 is well designed, data communication has evolved since the inspection of version 4 in 1970. Moreover, it has been used for 32-bit address initially. Nowadays, we are adding more number of bits or more number of graphics or graphical resolution so that we can use IP version 6 for making a better connections. IP version 6. So the IP version 6 are based on previous version IPv4. So in this method, we can able to transmit more number of data at the same time. We are performing the data as 2 power n. So here they are using 2 power above 32 model, so that it's just making the connections based on the number of floating points. So initially the headers are 40 bytes and the payloads are maximum 65k, so that it just make it connection at a make it more number of connection at a single time. So those all the 60k bytes are coming together based on extensions based headers and data packet from the upper layers, because we just making the connection and forwarding the information as floating point units. So each bit has been assigned and their corresponding information has been listed out here. First one is mapped address to the IP version 4 or IP version 6 based on the bits. The value of version 6 priority field is discarded. Next one is the type of service field in IP version is set to 0. Next one is checksum model has been checked. Next one is IP version 4 flow label is ignored. Next, computable extension headers are maximum added. The length has been calculated with the help of this number of packets received. Last one is the total length of the IP version 4 packet along with the corresponding field. While the header has been designed based on the above parameters only, the headers are the medium which is used to communicate the data to the next level. Format of IP version 6. So the headers are communicating the data to the next level by forwarding the information as header based on the header length, because the header length only decide that what are the information has been forwarded to the next header, so that it just make it as a connection, and that it hold the information of the previous data and it is communicated to the next header level. So like that all the headers has been received based on the number of bits to be forwarded. So the number of bits are here they are given about 8 bits. So here they are forwarding number of bits as 8 bit. Every 8 bits each header has been forwarding the information to the next headers. Priorities. Sometime if you want to transmit the high level data to the next layer, we need to go for priority model. So we can make our header connection as the following method, because based on the priority only we can able to send the data. So this model alone, this header alone send the data as a priority one. First one is 0, no specific priority, background data, unacted data traffic, reserved attended bulk data, reserved interactive traffic, and control traffic. Because we are sending the data as a priority one, so we need to check the congestion model, because all the data are assigning while forwarding the information. So that we need to allow the corresponding the factors to the next level. Extension headers types. Sometime if you want to add more number of priorities to the headers level, means we need to assign the header level by hub to hub option, source routing, fragmentation, authentication, encrypted security, and destination region. So this has to be followed while checking the adding the more number of priority data to the header level. Transition from version 4 to version 6, because we are updating the data from version to version 6 means it takes a considerable amount of time before every system in the internet. so that it can move from IP version to 6. The transition must be smooth to prevent any problem between version 4 and 6 systems. So the transition. So while transition, the version 4 to version 6 need to be check the dual stack operation and tunneling and next header translation, because already we have discussed that header, each header receive only 8 bits, 1 byte. So every header has to be need to check the data which is to be forwarded to the receiver side. Next one is where same data has been forwarded from the source to destination. This needs to be checked in the dual stack. Next one is tunneling. It is a bypassing method. Sometimes it may not be checked, or high level priority also not checked with the corresponding IP version 6, so that it is tunneling method is used to find the cross over the boundary of the corresponding data. Dual stack. So the dual stack is a method. Both the version 4 and version 6 has been assigned here. The version 4 is allowed only for the limited number of data, whereas version 6 is used to transmit more number of data at the same time through the floating point model. So tunneling strategy is, tunnel means it is a bridge while sending the data. Sometime the version 4 has been checked once again through this tunneling model, and then it can able to communicate with the other receiver side. Header transition. So same process. IP version 6 is while checking to move towards the other end means you need to check by IPv6 header as well as the payload operations. Assessment. The comparison between IP version 4 and IP version 6. Already we have discussed the IP version 4 is only used for 32 bits. Beyond the level of 32 bit, we can use IP version 6. The authentication extensions are almost loaded by IP version 6. The fragmentation also more number of header section in IP version 6. The timestamp also implemented more number of level in IP version 6. The record route also having more number of version in IP version 6. Thank you.